Hey everybody, and welcome to the next chapter, Miscellaneous Subset Selection. So believe it or not, there are actually a few more ways to select subsets of data other than the ways we've already talked about. So Pandas does give you an enormous amount of ways to select data, and this video will cover those. All right, so we're going to begin with the query method, which is a method that allows you to do subset selection by writing like a string to do so. So this looks more like you're doing some sort of SQL command if you're familiar with SQL. So you're just writing a plain string into the query method, and it will return a subset of the data. Let's go ahead and read in this bikes data frame, and I'll show you how it works. So let's go ahead and replicate something pretty simple. So before I begin, the query method is used to do Boolean indexing. So it's an alternative way to do Boolean indexing, and a lot of people like it because it's a little bit more readable. So let me show you an example here. So you do dot query, and then you open up a string, and then you simply write in the query that you want to do. So you can write the column name just directly as it is that you want to, the one you want to create the condition on. So trip duration, and let's just get all of the trip durations that are greater than 1,000. Okay, so it's as simple as this. So it's, the syntax is a little bit simpler, and we can verify that it looks like it worked. All these rows have a trip duration greater than 1,000. So that's nice. Now, if we look below, I have the syntax, the old syntax, which is a little bit more hard to read. So you see the word bikes twice. So this is a little bit simpler, in my opinion, when you use the query method. So let's go ahead and see if there's several more things you can do with the query method besides this simple subset selection here. Let's move on over here. So you are allowed to use the strings and, or, and not. You don't have to remember, you don't have to use those, the ampersand, the pipe symbol, or the tilde. So for instance, let's say we want to query the bikes data frame, and we want to say we want trip duration greater than 1,000, and we want temperature greater than 95 or something, if this even exists. Oh, there's actually one lonely person in the data set. Let's just see, get a little bit more data. So nobody's riding a bike for a long time in hot weather in Chicago, or just doesn't have too many days above 95 degrees. All right, so so you can use the actual string and, the word and, instead of the ampersand. You can also use the word or, so this will return, do an or condition. And you can actually place the word not in front, and you have to be careful here. So sometimes you can use a parentheses to make sure that you're what you're taking not of. So here we're just reversing this entire thing, or else not will have precedence over the very first, the very first one over here. So do not trip duration or temperature greater than 90. Okay, so that's some of the basic usage of the query method. So you can do simple multiple condition Boolean selection with the query method, with just directly with strings like this. No creating a filter or using the ampersand or the pipe symbol. You can just do directly like this. So it's definitely more readable, in my opinion. So one interesting thing about the query method is that you can use this and symbol to reference a variable name in Python. So let's just say I have a trip duration variable over here. Let's just say I have an integer over here called TD. So we're going to assign this to the value 1,000. Well, you can actually use a variable within the trip duration, or within the query method. So we could say trip duration is greater than, you use the @ symbol and you use TD here because our variable name is TD. So if you don't use the @ symbol, Pandas will try to find the column TD, and that won't exist. So this is alerting Pandas that this is in fact a Python variable, and not a pandas column name. All right, so we have that. So we're saying, is it greater than 1,000? So that does the same thing as above. So that's how you reference variable names with query. All right, now you can reference strings. So the way you do that is by creating an inner string. So let's do this. Let's just say we want to find all the bike rides that were done by a female. So we can say bikes.query, and then we're going to use the gender column here, and we're going to say equals equals, and actually put the string female in here. Now notice I started my query string with a single quote, which means that Python allows me to put double quotes in here, to put a quote inside of a quote. So this is perfectly valid. So this is anything without a quote is going to reference the column name itself. So gender, without any quotes around it, it will reference the column name. If you put quotes in here, then pandas will treat this as a string. So it's going to look for gender equal to female, and it looks like that has worked. All right. Moving on. Okay, I already have this one written out. So remember how we did the isIn method to test multiple equalities? Well, you can do the same thing here. You don't have to use isIn. You actually, so what you do is just use the word in, and then you create like a list inside this string. So it's a little bizarre looking, but we created the list just like this before, so it's no different. But we, here we're, we have to put strings around the actual events, rain and snow. So that's how you would select, events that only were either snow or rain. So you go over here, we can verify that. Okay, so there's a little bit more to the query method, but this covers sort of the major things that it can do. So why I avoid the query method? So number one, it's not as common as just doing the brackets. And one of the major reasons is that it doesn't work with columns with spaces. So if you have a column name with a space in it, the query method is going to fail. Now this may be alleviated in future versions of pandas, but at the current version it is not. It does not work. So I like to use methods that work 100% of the time, regardless of what you're doing. So if you stick with using just the brackets and normal Boolean selection, then you'll be able to make any selection you want. So, but you're more than welcome to use the query method. It does have, I believe, better syntax, and it's easier to read. Let's move on to another type of selection here. This is something I'll just go ahead and say I definitely avoid doing this, but I want to show that it does exist. I don't want to completely ignore it because you will see this. So when I told you about using just the brackets, so we learned about just selecting a single column of data like this, putting the string in there. We learned about selecting multiple columns by using a list. So let's just select start time and trip duration. And then we did some Boolean selection. So we made a comparison in there. We put a filter in there. So those are the three main ways to use the just the brackets, is with a single string, a list of strings, or a Boolean series. Now pandas does something a little unusual. Allows you to use slice notation in here. So let's just say I want to get the rows from 10 to 15. So what's going to happen is that you can use slice notation to slice the rows. So the reason I don't like using this is because it's rather confusing and ambiguous. So typically, whenever you use just the brackets, you're either going to do, you're either going to select one column, multiple columns, or do Boolean selection. Now, if I'm going to, do slicing like this to slice the rows, and I'm using, integer location, I'm always going to use .ilog to be explicit. So I really like when my code is, I'm 100% sure what it's doing. And the reason for that is that, you might think it does look explicit. Well, it's not technically an explicit, we don't know if this is integer location or by label. So if you're, if your integers in your index are integers but are maybe like in a different order or something, you're not guaranteed to get to use. It's going to use integer location. So I always use iloc when I'm doing slicing because it's explicit. That means I know for a fact, 100% sure, that when I see numbers in here as a slice, it is definitely doing integer location. If I see .loc as my indexer, then I know it's doing by label. So to be explicit, use iloc or loc. And although this does work, I would suggest not using it. All right. There's another set of indexers that I don't use, but I want to show you that they do exist. So these are at and I@. So at and I@ are used to select a single cell of data. That's all they can do. They can only select a single cell of data. So let's actually read in a different data frame here, and we'll just read in the movies data frame. And we will set the index column to the title of the movie. And I did not provide .csv. Okay, so it's movie. All right, so let me just stick with movie. Apologies for that. All right, so I put the title in the index. Read in a new data set. So the way at works, it's another indexer. It is similar to loc, so it only selects labels, but you can only give it a single label. So that's the only way it works. You have to give it exactly one row and one column. So if we want to get Forrest Gump, and we want to find the duration of it, we would do this. So Forrest Gump is a movie that is 142 minutes in length. So that's how this works. So any other, you have to use a single label for the row and the column selection. Now, I@ is analogous to iloc, so you have to give it a single integer. So for both the row and the column selection. So let's do 105. I have no idea what movie that's going to be, but 5 is 0, 1, 2, 3, 4, 5. So it should give me, let's do 4 so we can get a name, the director name here. So some director named Rob Cohen has directed the movie at integer location 100. So you might wonder, why does this even exist? So this is both of these are possible by using loc and iloc. So there's I can use loc there, and I can use iloc here to do the exact same thing. Now what Pandas does, it provides a little bit of performance benefit when you use at instead of loc. So it does it a little bit faster. So it's optimized to do just this one operation. Now the optimization is actually not that impressive, and it doesn't give you that much of a speed up, which is why I never use these indexers to do a single cell selection. I don't recommend using them. I recommend sticking with loc or iloc, just so you can cut down on the number of indexers you have to remember. There's already 3 indexers, the brackets loc and iloc, so adding 2 more to your repertoire is just asking to get confused. So I tend to avoid these. I do avoid them. So if you do want actual performance, then you can use NumPy selection instead of Pandas. You can drop down into NumPy and get much, much faster performance. So let me go ahead and show you this real quick. So I'm going to show you, I'm going to time 3 different selections. I'm going to time, I'm going to time with NumPy, which is values, I@, and I should have done at right here, actually. Actually, I'll keep it iloc. Okay, so what I'm going to do here, what I've done with values, so I've gotten the underlying data in a NumPy array, and let's just say I want to do integer location. So I just want to select a single cell from this NumPy array. So again, this NumPy array contains the exact same data that the data frame contains, but it doesn't have an index and it doesn't have labels. So NumPy does integer location selection. So here we go. We're going to time this. So we're going to take values. We're going to take the I guess the 30th one from the bottom and then the 5th column. So it's rows, comma, columns for NumPy. Here this says this is a command that will time things for you. This is an IPython magic command. So I'm not going to really explain this other than it's just saying it's doing 5 loops of 7 runs here. So IPython will figure out what the optimal number of runs are for this particular number of loops. So so it says it did this in 383 nanoseconds. Now if you do I@, you're going to get here, so it's 15 microseconds. And if you do iloc, it actually beat it somehow. So, but anyways, the important thing here is to notice the dramatic difference between NumPy, which is in nanoseconds, and then I@, which is in milliseconds, or excuse me, microseconds. So this is about 50 times faster, approximately maybe 40 times faster using NumPy over I@. So I@ should beat iloc, and maybe because I'm taking a video here, it's it's sort of all over the place. So there's a lot of stuff going on. But here I@ was actually faster than iloc, but it's still much slower than using NumPy. So if you really want performance, then you should look to NumPy. Get your data into a NumPy array if you want a big performance increase when you're doing a subset selection. There's really no reason to use I@. All right, so that covers all this miscellaneous selection that didn't fit in nicely anywhere else. Most of these things are some things I don't actually use, but I wanted you to be aware of it because you might come across it, and if you are interested in it, you can use it. But it's just my suggestion that you probably should not, because it doesn't really give you any other functionality than what's already in pandas. Okay, so that does it for miscellaneous subset selection. See you guys in the next video.